In this session, we're going to be covering the source to staging. We're going to be looking again just on a recap on the BimlFlex workflow, source to staging control flow, the source to staging data flow. We're going to look at the source query SQL object options that we have, and also on the source query inherit object options. And then I'm going to demo all of this for you. So the first thing we're going to look at is the BimlFlex workflow. As discussed in the previous session, we import the data. We import the metadata from the data sources, and that could be any data source that is supported. The metadata is persisted in our metadata database. We then pull those metadata back into Biml Studio, where we are looking at the templates, and in this case we're going to be looking at the source to staging templates, and then we're going to be building out and deploying that code. So we're just going to be building it out. So we're really looking at this whole section number 2 here, where we're looking at changing some of the metadata and then opening it and building it in Biml Studio. Let's first look at the source to staging control flow. So as you can see, there is quite a lot involved there, but effectively the key things to remember is the sequence main, which effectively is everything that is executed. So that's the control flow. If we add parameters, it'll have a get parameter section and a set parameter section. You'll use that for, when you are looking at implementing, change data capture or implementing change delta loads. You'll be defining parameters that gets persisted and says I've loaded from this point to that point. And we'll briefly touch on that in this section. We also have extension points called pre-process and post-process. Now this is where you may want to execute any supported piece of Biml code that runs before you actually execute your main, and then after you've done it, you might want to do something over here. So this could possibly be reading a variable from another table to give you some context, and then the post process may even be something like sending out a notification or email. So it's anything that you want to put into your pre-process and post-process. Anything marked in these templates with these sort of orange or red color and a dot there means that derives that you can have an extension point. So even on a get parameter, you can override our default get parameter process with a get parameters extension point, and the same with set parameter. Override main actually allows you the ability to completely override our custom framework. So you may have a situation where you have such a complex piece of SSIS code or Biml code that it doesn't fit within our framework, but it is only for one table. You may actually decide to actually just instead of using our standard template for that one table, completely override it with your custom code. The sequence main, if we break that out, it is actually, we will initialize our staging, and as you can see here, there's an extension point to override initial staging. So initialize staging is a truncate of the staging table. It may be a scenario where some of our customers have said, well, what if I want to run 5 or 10 staging loads and then run my data vault load or my data mart load based on a number of staging loads? Well, what you want to do there is create an override initialize that just do not truncate that table, and I'll just override it with select 1 equals 2 or something like that. Lookup cache, lookup SQL, lookup parameter is used in your persistent staging. When we do persistent staging, and I'll touch on that a little bit later on. Some of the stuff will actually make more sense once you see the outputted packages, and I'll show that to you. And again, you can kind of override those with extension points, or actually they are extension points. You also have the pre-data flow. In other words, before this data flow runs, you might want to throw off another data flow. You might want to execute something, and a post data flow extension point. Then after that data flow is run, you might want to do something there. And then we have the persistent staging. If we are doing persistent staging, there will be a merge statement that merges your staging data into your persistent staging. But all of the real meat of it happens in this extract source or this data flow task here. So let me go into that for you. So this is the default structure of our state data flow, and as you can see again, we've got a number of extension points here. We've got a source pipeline. In other words, if you need to do something in the data flow just after the select row count, or if you want to do something just before you insert it. And the reason why we have these two different ones is that you might want to derive some columns that is used in this path here, or you might want to do something with columns that is already being derived over here, which is a target pipeline. And then on the source SQL, what you'll see here is we'll have it split into left and right. The left side here is metadata overrides or metadata extension points, and the right here are Biml extension points. So what we'll see when we get into the object tabs, you'll see that you can append a join SQL, a where SQL, a group by SQL, an object alias, and we'll look at these guys here, SQL expression and a column alias. Not so much in this. Actually, we'll look at some of those inside of the session, and then you can also, this whole source query here, you can completely override it with a source override. Where we've seen that being used is where some of our customers have had a situation where they need to connect to Zero, or they need to connect to some form of a web application or API, and it's just not a standard component within SIs. What they'll then do is they'll create a standard piece of Biml and just completely override the source query here. Override SQL. So BimlFlex will create a SQL select statement that will extract the data from your source query. Again, if your source query is very custom or very complex, and you may actually say, you know what, for this query, use this piece of SQL that I've pre-written for me. You can use the source SQL. The source property is just properties that we can set in the configuration settings. Those are things like you know, where on the connection we can set some properties there, and I'll show you the source property. That's things like, oh well, you know, delay validation and things like that. Those are SIS properties that you can set. So we'll focus quite a bit on this, because ultimately the rest of the pipeline really is just standard things where if we've added any columns that needs to be derived or alternate, or you know, derived columns or alternate columns, and I'll demonstrate that to you. A surrogate key, a business key, you know, do we need to hash those? Are we hashing it into our staging layer? Are we doing, if we're doing data vault, we'll do quite a bit of this, the hashing stuff here. We add our audit columns, the BimlFlex audit columns. If we are doing persistent staging, there's a persistent staging compare section here, and then we just insert it. We add a row number there, and we insert it into our staging table here. And then again, we have the target override target properties. So I'll demonstrate most of that for you, but let's go into the things that you will use quite a lot of, which is the SQL objects in the metadata. So what we're looking at here is in the Excel BimlFlex Excel add-in. On the objects tab, we have the join SQL, the where SQL, the group by SQL, and the object alias. So we'll look at those first. In the next slide, we'll look at these ones on the side here. So the join SQL is if you are using a table and it requires a join statement. So give you an example here. If I'm putting on the address line here, I'm putting an inner join to this customer address because I only want to extract addresses that is relevant to the customer address that has a link to it. On the where SQL, I want to go and say, well, I want to take that a little bit further. I say, well, because I've now joined to my customer address, the alias being CA, I'm saying I only want my main office addresses. So that immediately gives you the ability to say where my address type equals main office. Group by SQL, you know, you can use the group by clause, and in this case here I'm saying group by customer ID, order by customer ID, so that'll go into the group by SQL. This you tend to use if you are writing queries that are doing aggregation. So you may want to have a query on an object that says, you know, select, and it quite often goes with also with sort of I suppose custom queries, where you may want to have something that says select customer ID and the sum of sales. For whatever reason, you might want to do that. Well, to do that, you know, what the query will be generating is select customer ID, you know, the sum of the sales, and then from, and then the where clause, and then we'll add the group by clause into it. I'm not going to be demonstrating this, so it's a little bit of a corner case situation here, but just be aware of it. And then the alias defines the sort name. So object alias there in this case would be this word source here, and I'll show you in the next slide where that comes in. And it's generally defined in conjunction with a join SQL and a where SQL. So it's where you are bringing two tables together that you want to alias the first object. So this will be the alias of the address table. And we recommend using SRC. A lot of the examples, I just know source means that's my source table, and then alias the rest of it. But again, that's a personal preference. Let's look at this in action. So I've created this office address here, table here, and I'm saying I'm going to create an inner join here, and I'm going to create a where clause, and I've aliased this object. So the source, as you can see here and there, will be appended to my query, which is my object alias. The inner join will, so this will be the standard query. So if we take the source away here and here, That would be my standard query if I had none of these, if I didn't have a join SQL, where SQL, and an object alias. Then we'll add the join SQL, which sits down the bottom here, which is joining these two columns together, and then the where SQL. So at the end, after we've added these metadata attributes into my spreadsheet, this is what my query would look like. The source query inherit object options. Now, before I get into this, I just want to say that it's probably not going to make a lot of sense of what I'm explaining right now. It's better looking at this with a real world or real practical example, and I'll explain it to you further, but I'll just explain this to you, I suppose, the definitions of it. So inherit from object is something in the context of, well, if you want to inherit, if you want to create an additional metadata object here, but you want to inherit everything for this object is actually the same as the address table here. So if I look at this previous slide here, I've created a table called office address, and I've actually, what you can't see in this slide is that the object inherit settings have been set. So what I want to do there, what I want to do there is I want to say, well, this table is the same as that table. So it kind of says, well, use that table, and then the same as inherited means that the table that I'm inheriting from, this table is exactly the same as that table. Now what you will do is use this in the context of, let's just say you have an ETL load process where you are incrementally extracting, so let's just say address table here. So during the course of the day, you are incrementally extracting changes from that table. So you're just saying, yep, get me the latest address. Great, get me the latest changes, get me the latest changes. And then possibly at the end of the day, you want to go and say, right here, I want to still extract the address table. So it's the same table, but I actually want to have a different sort of join SQL, where SQL, because now on the address table, I want to extract the whole table. So I don't want to filter or have a parameter set on that table. Then what you'll do is you'll say inherit from address, and it's the same as inherited, and it'll create a second package for you that looks exactly like the same price, the first package, just with different metadata. And I'll demonstrate that to you. It's going to look, when you see it in action, it'll make a little bit more sense. And use inherited name effectively says that this second table or this new object that I'm doing is when I write my source query, the name that I want to have in the from clause, I need to use it, the inherit from object table name there. Again, it's going to make a lot more sense once you see this in action. So let's go through that and actually demonstrate that to you guys. So what I've got here is I've just got my metadata that I've imported. I've imported the fresh set of metadata with just the defaults from AdventureWorks here. And now I've got the sort of join SQL, where SQL, group by SQL, and inherit from object, same as object. So the first thing I'm going to do here is just create a bit of metadata that actually just shows you all of that. So all I'm going to do here is just go and insert a row here, and I'm just going to paste in one that I prepared earlier, and it's got everything in it. So what I've done here is I've created a new object called office address, and in this office address I'm creating an inner join to the customer address table, and I'm using the where statement here and saying where it's main office. I'm aliasing it with source, and I'm providing and saying, well, this is the same as that object, so it's the same as inherit object. Now you don't need the schema here, so I can take the schema out. If the schema is not present, it'll actually look within its own schema and finding the address. If, however, you have sales, let's just say you have something called sales address, and you have purchasing address, and it needs to go to the purchasing address, you'll need to add the schema here so that it knows what to do. Same as inherited in saying that this table is exactly the same as that, so I don't need any columns on this table, and I use the inherited name. In other words, in the select statement, I'm going to use the inherited name. So I'm just going to go and push that up. Okay, and effectively that's all I'm going to do right now, and I'm going to go ahead and actually build this out. Alright, so I've imported the metadata here, and the office address would not be here because obviously I've got same as inherited, so it will not create a second table because it's the same as the table we're hearing about. But I'll have this extra ETL process here sitting office address over there. So if I'm going to build this out right now, so I'll just go and hit the build button here on my Biml Studio. What I'll see is building out this additional package here with that query there. Okay, so that's built out. So I'm going to go ahead and open this up in Visual Studio right now. Okay, so it's opening up the solution here, and here you'll see the office address. So if I open up office address here, the table, the package here, the output package here, we'll see where it's actually added that metadata. So I'll go into the data flow task, into the source query, and you'll see here that I have now got the inner join is added and the where clause is added there. Okay, so that means how it is, and what you'll see here is it's selecting from sales LT address. Okay, and the reason why I've done that is because I've said in my metadata I have said that it needs to use the inherited name. Okay, so that's one way of adding a table. The other way of doing it is if I wanted to say office address, actually have to create. So this is a situation where you're saying, you know what, I've got an address table here and I'm going to create another address package, not another address table. I just want to create a second address package that has another piece of output. But let's have a look at this. What if I wanted to actually create a physical address table in my staging layer, because now I want to do and go and create. So what we want to do there then is go in here and say, you know, yes, it's not the same as inherited, so I'll take that out because I'm now going to change this table is not the same as that. I'll set that up. Then I'm going to go into my columns and I'm just going to go and do this pretty quickly. So don't this is not done here to be I suppose super sort of modeling perfect. I'm just going to grab this columns here and I'm going to just do everything that I've got here. I'm not going to change it, and I'm just going to go and drop this in here again, create a second set of that tables, and just change this to office address. Okay, and grab that and bring that down here. So I'm creating exactly the same table. I'm just changing, I'm just creating a physical table now. So I'm giving it its own columns and things. So I can now model this going forward. So I'll set that up. So if I now go into Visual Studio and now refresh it, I will now see the tables coming in. So there's the two different options. The one is cloning the metadata off another table and just creating a secondary package of it, to maybe, as I said, the one package maybe being a full load, another package being an incremental load. What you'll do there is you say it's the same as inherited, and you will basically just create a second package and focus on the joining scale stuff. The second option is actually to say, well, I am inheriting from that table, and I want to use that table's name effectively in the select statement, but I want to create a physical second table here. So here is office address now. So just before I'm finishing off, just before I finish off, I'll show you here that in this package, my destination here will go into address. Okay, so if I now build out the solution, which I'm going to go in here, I'm just going to first go and generate the scripts here because I've now got an additional table. I now need to create the office address in my staging layer. I'll pop back in here and I'll just drop it in here and just run this in. And then what I'll go back into Visual Studio is I'll go back in here and just build this out, because now I want to build out the new section. I'll open that up. So that's running, and I'm going to hit the build button here, and after the build we're going to go and look at the package and see how the package has changed. Alright, so we've got a successful build here. I'll head over to Visual Studio here and I'll say reload all. I still have the office address package here. I'll go back in here, I'll have a look at it. It is now a physical table. I look at my source query. The source query still looks the same. It still gets it from sales LT address. However, and it's the same query there. However, my target table now is going to office address. So that's the way that you can actually play with those settings and saying, you know, and a number of these things would be different. You would also use this in the context here of possibly creating something where you would have a full load or AdventureWorks delete. So one of the things that our customers quite often ask us is, if I have a table here, and let's just focus on address now because we are in address here. So let's just say we're focusing on this address table here. How do I identify, because I'm now building an incremental load process. So I've got an incremental load process here that pulls the data from the address table, and then every time I load it, I just get the changes. And I never really know when there is a delete on it. So let's just have a look here and see how we can do it. So remember, I'm persisting the address table here. My address table is being persisted. I've associated with this project here called AWLT, and I've now created a secondary project called AWLT delete. So what I'm going to do here is I'm again going to grab this, and just for the purpose here, make up your own naming convention. I'm just going to put the word _del behind it. So I'm creating a second table here, which is going to be a delete table that is only going to do and derive the delete set. So for that, obviously, I want to have the minimum amount of information to pull. So effectively, all I really want for this table is the business key, right? Because that's all I need to go and identify changes. So what I can now do is I'm going to just go and grab this stuff here. I'll just go all the way to actually I probably need the address ID, but I'm going to grab these two columns here. Let's see. Because there's a multiple business key, I need both those columns. Otherwise the FlexDB will fail. So I'm going to go and grab those two columns and I'm going to pop this in here. Okay, and I'm just going to change this to, I want this to be address delete. Okay, now one of the next things we need to do here is we are persisting our system. So in other words, what our persisted staging will do is it will actually look if anything has changed in this table, and if anything has changed, it will only save those changes. But in this case, I actually want to stage everything. You know, and this is where, because I've got this in a separate batch and a separate project, I can actually execute these identifying of delete records. I can actually execute that once a month or once a week, whatever frequency I want. But to do that, I actually need to go and say, well, you know what, this actually on the projects here, I've not set that to be persisted. So on the project here, I've not set that to being persistent. I could have also gone and on this is not persistent, go and set this to no, don't persist this. So on the columns table here, I'm going to go and set current sheet. And again, I'm going to go back into Biml Studio and just refresh this. So what I'm going to do after I've refreshed this, I want to obviously see a table coming into my staging layer called address_del, not into my, okay, so it's in my persistent staging layer. I've made a mistake there. I have not associated it with the correct, the object with the correct project. That's the reason I've made the mistake there. So what I want to do here is associate this with this project here, the delete project. I'll set that back up and then I'll go back and refresh my Biml Studio. So yes, sometimes you do make these mistakes and you just got to be aware of those. So if I refresh this now, that should go away and I should have the delete here and not there because I'm not persisting it. And then I'll have my additional package here and I should have a secondary batch coming through here in any second now, an additional batch and an additional project. Okay, so there I've got my delete batch, my delete project there, and I have this additional batch project here. Again, I'm going to create the tables and I'm going to build it out. I'm going to create the tables now and build the project out. Okay, I've built the project and it's failed. It's come back to me and says, well, this table address DL does not exist in the source query. What I should have done here also is gone in and said, well, you know what? I needed to say that because obviously this table address DL doesn't exist. So I needed to really do this bit here, which I've forgotten to do, and push that up. So I'll do that, I'll refresh the metadata and I'll build again. Alright, so that's built. Let me head over to the Visual Studio, have a look at it. Yep, I'll hit reload all. So I should have now an additional file coming in here. So as you can see here, I don't have this over here because I've built it into a separate project. So if I were to go and open up that project, I now have the batch and I'll have this address delete piece of code here, which will effectively just select from it and insert into there without any persistent staging stuff. But what if I want to have it as part of the same SIS project but just in a separate batch? So I don't want to have it in two separate SIS projects, I just want to have two separate batches. How would I do that? Well, let's head back over to BimlFlex here. So I've got these two projects here, VentureWork LT and delete. So I'm going to actually go in and insert another one here. And I'll just grab the top one here, okay? As you can see here, when we don't have the right things set, we can have those things there. And I have this validations inside of Excel telling me where my mistakes is in my metadata. So I'm just gonna rename this one here to let's just say extract adventure words. Okay, and then I'm gonna say this is my parent project of these two. So now those two guys belong to the parent project here. And yep, I'm gonna leave everything else as it is, and I'm gonna go and set the current. Just gonna set that up, and I'm gonna go back into Biml Studio. So what I want to see happen now when I hit the refresh button is I want to see the two batches, but I want to see one project called ext_aw. And let's see what happens there. What I now have is I have my two batches and I have a single project. So if I hit the build now, I'll get all of my packages and my batches into a single size project. So let me go ahead and do that. Alright, so that's built successfully. Let me head over to Visual Studio, and I have to now open up a separate project, the parent project effectively, which will be this one. And inside of this project, you'll see there is my one batch, second batch. There's my deleting of the address, which I'll open up for you. I'll show you here that, yep, it just goes and initialize staging, loads that, as opposed to the other address table, which has persistent staging in place, which will actually go and initialize it, load it up, and at the bottom here of this package, do the persistent staging check and only transfer the records that doesn't exist in persistent staging. In other words, the deltas will go through into the staging layer. So how would you now use this, right? So if you want to identify deletes, now you have the full set of data here. You also have the full set of, I suppose, data in your persistent staging table. And now you want to say, well, I need to go and identify and saying, do a join across these two tables. So let me show you in our PowerPoint slide deck again, where that would come into play. So if I were to look at this slide here, what I have here is I've got effectively a sequence main that has the initialize and has the extract source. After I've extracted the full address table for the delete purposes, I want to go and do a post data flow extension point to say, with this information that I now have, go and do something, go and identify deletes, and then once I've identified the deletes, the deletes that I've identified, go and probably insert the deleted records into the staging table with a deleted flag. Okay. Now I'm not going to write all of that SQL for you, but I'll just give you an idea here. So within BimlFlex now, the easiest thing to do here that I always do is I just go and look at this, and I normally this is my workflow. Yours could be different, but I'll just go and copy the Biml here and drop the Biml into a separate file. I'm not going to go and I'll just drop it into Visual Studio here. I'll go right to the top. And here is the thing that you want to grab, is you want to grab this object entity here, which is the fully qualified internal name. Okay, so I'm going to grab that name there. Then I'm going to hit back over to Biml Studio. Now what I want to do is I want to insert an extension point associated with this. We have a number of extension points that are documented, but the one that I want to do now is on the object, I want to go and insert a post-process extension point. And what we do is we get a sort of pre-filled out example here. The one thing that we can't fill out at the moment is the target. So what I want to do here is saying I'm going to target this table that I've just created, right? So I'm going to target that process here on the post process, and I'm going to go and insert this code here. So I'm going to work through this a little bit. I'm going to show you some of the I wouldn't say mistakes, but some of the things that maybe catch out some of our customers. So I'm just going to do that. And in here, really, I'm not going to go and write it. So what you can write in here is you can, let's just go and write a real quick query here. So if you think about what we're going to try and achieve here, is on our staging database here, we are going to have this table here. We're going to have this address BK here. And on our ODS table, we are going to have this table here called address, 5 and 6, all right? So what we want to do here is we want to go and say, we want to start from this table, and we're going to go and say, well, left outer join it onto, you know, this table here. Because we're doing a cross database query, we probably want to do this. And we're going to go and say, listen, let's just call this D, and then we call this A, delete and address, and we're going to go on the address business key here. Okay, so we're going to go you get the idea, right? And I'm just going to go and grab from here. I'm going to from here I'm going to go and grab just a dot, and you can obviously add as much SQL logic here as you want. The only other things you need to be aware of here is you need to say where you either can use the row is current, or you can use the end date, depending on how your indexes are defined. So I'm just going to go with the row the effective date. In other words, is equal to identify just the latest change here. So refresh my metadata there, and then obviously last but not least, I want to say and this is null, right? So I may not have this perfect. I think I've got it right, but you know, if I don't have it right, you kind of understand what it is. So what I should get here is I should get all the business keys, right, that exist in my persistent staging, that does not exist in my full load. Effectively, according to this should be deleted, right? So this is my query here that I'll go back into and just drop that into my direct input here. I don't have any variables, so I can actually take this out. I don't have any parameters, so I can take this out, and I'm just going to go and call this. Now, what you want to do, obviously, with this is you actually want to go and combine this, and actually from this go and insert records into your staging table, your address staging table, to be loaded as with a deleted flag, right? So just aware is that this is very just showing you a demonstration of what we're doing. I'm not going to go into much detail. The other thing is that there is a way to derive this, but the other thing I'm going to do here is to say that this is going to go on my ODS layer, and I'm going to save that. And you will obviously then go, your extension point would sit down the bottom here, you'll give it a proper name. But all I'm going to do right now is I'm just going to right click on this and refresh that one, and then we're going to build it out and see where this goes to. Extension points is an advanced subject, and it's got a lot of things, that inputs and output variables and all kinds of stuff that you need to be aware of. But for now, I'm just going to build this and show you what it's going to look like. So if I look at the address delete package, there's the source sequence main, which has again got my initialized to my staging, but I've added this sort of get post process. So this is the sequence container that has the post process, and in this SQL statement here, you'll see there will be the SQL that I've got. So within the post process, you can then inject any logic that determines what the deleted record is and what I suppose what the output of that should be. So hopefully that's given you a good overview of the source staging layer. There's a number of other things there. You know, if you've got CDC enabled and a number of other settings like the configuration settings, which we'll touch on as we go through this series. But for now, you really should be able to import your metadata, and from the metadata define your, I suppose, your source staging layers, and then build it out. The only thing that I'm going to show you now is I suppose a simple way of defining a parameter set, a configuration value set. And we're going to head over to our parameters table here, and I'm just going to grab a column here. Again, I'm going to just work on the address BK here, and I'm going to just grab this modified date here, and I'm just going to go into the parameters and say, you know what we want to do is we want to define a parameter here, and I'm just going to go and call this the last load date. This is the name of the parameter, not the column. I tend to use last load date or last modified date, whatever it is. And every time I load, I want to load greater than the previous load. The first time I'm loading, I want to go and, you know, obviously load all the data. So I'm just going to insert 1900. And the data type, when I'm working with strings, SI is a little bit temperamental. When I work with date times, I always cast it to a string. And the parameter SQL is that at the end of the extract, what SQL statement should I run to get the next load parameter? So just when I'm working with dates here, I normally just use this. So I'm going to say convert to varchar, and and I'm just going to go and grab 10 bytes here. Sorry, I'm going to stay in there. Bar chart 10, and then I'm going to say comma max at this. So wherever in the framework we use the, I suppose the keyword at this, it means that replace the at this with the column name. So that's great, because now if I have a number of date variables here, I don't have to go and write a parameter SQL here for every one of this. And I'm just going to go 120 there, which is again, that's the SQL statement. So what it's going to do is it's going to say, after I've run from my staging table, select the max last modified date from this table out of my staging table, and you give me that parameter. Parameter column expression, SQL expression, override, those things we'll cover when we work on parameters. Parameter ordinal is 1, I've only got 1, and I'll set that to current sheet. I'll head back over to Biml Studio. So what I'm going to do now is I'm going to go to Biml Studio, refresh my metadata, build it out again, and then I'll open it up in Visual Studio and show you where that parameter has gone into. Alright, so we've built successfully, and now we're going to head over to Visual Studio. We're going to say reload all, no, and then I'm going to look at the address table here, the package here, open that up, and what you'll see is you'll see the get parameter sequence container, which will get the last load date. This will get the load date from the, and I'll open it up so you can see, it gets the load date from the get configurable variable in the Biml catalog. That is where we persist the parameters. It does the normal load. It would have now gone into and added to my source query a where statement. So where modified date greater than that. It adds the parameter pointing to the last load date variable, and at the end of it, after it's loaded, it goes back and it goes and set it. So the first thing it does is it runs that select that at this, so it runs the max modified date from a VentureWorks LT, so the LT address from the staging table, puts that into a parameter, and then goes and set this into the configuration variable. So this goes and sets the configuration variable, and now next time I'll run from that point. You'll use the same mechanism we use the same mechanism here for our CDC patterns. So even if we have used SQL Server CDC, we use that to go and set the LSNs and get the LSNs. So that's a quick run through of the source staging layer. We go into this in a lot more depth in our training sessions, but for now I think you should have a good overview of how you would import your metadata, take that imported metadata, add some additional metadata around SQL queries, where statements, join statements, possibly add some extension points if that you choose to do that, and then load that through. Thank you for watching.